Hey, what's up guys? I have a real treat for you today. We're going to NVIDIA GTC, the world's premier AI conference. For those of you that don't know, NVIDIA hosts this tech conference every year where world-renowned experts from all around the globe fly out to San Jose and share their expertise and research about the industry. I'm currently at the San Jose McEnery Center, right here at the heart of downtown San Jose, in the middle of Silicon Valley. This tech conference is one of the reasons why the AI industry is moving at such rapid paces. Whether it's autonomous vehicles, robotics, computer graphics, or machine learning infrastructure, if you can think it, you can trust that there's an AI company working day in and day out to innovate in that space to make the world a better place. Ever since I discovered my passion in machine learning, I've always had a dream to come to this conference, and now it's finally happening. So I'm really excited to share that with you guys. There are over 900 different sessions ranging across every subset of AI and machine learning that you can think of. In fact, if you missed this conference or the live streams, I highly recommend you check out the recordings on NVIDIA's GTC website, which should be available in about a month after the conference ends. I'm going to be sharing my experience here at NVIDIA GTC as a college new grad, and I hope that I'm able to share all the things that I've learned from these brilliant minds. So strap in because it's going to be an action-packed week. The first session of the conference I chose to attend was about autonomous vehicles and had a senior product manager from NVIDIA share the company's vision of the industry's future.
There's no way we can drive all around the world gathering all the stop sign data that we can. This is where generative AI comes into picture. You're actually generating new stop signs and creating corner cases like these where the vehicle still needs to ingest that data and understand it's a stop sign.
Hey guys, so I just finished the Introduction to Autonomous Vehicles session and it was incredibly insightful. There's a couple of key things that I took away. The first is how the use of generative AI is going to be shaping how our autonomous vehicles are going to be driving. For example, the speaker was talking about how a lot of different signs such as stop signs or do not enter signs may have rust or graffiti on them, making it incredibly difficult for these end-to-end deep learning models to understand what exactly the sign is there to portray. But thankfully, that's exactly where generative AI can come in, because they can simply generate new variations of graffiti and rust on these stop signs, and then this can be fed into the deep learning model to make it much more robust to new conditions and patterns that it may not have seen before. But the second really cool example that the speaker was talking about is the use of LLMs in our AVs. For example, let's say a family of 3 is crossing the street. Let's say the 2 kids run past their mom while she's taking her time. A human driver may see the gap between the pedestrians and choose to take it, putting the pedestrians potentially at risk. However, with LLMs integrated into our AVs, we hope that they're able to now deduce that, hey, because the 2 kids are running by, chances are the mom is going to follow. So I should probably wait for her to pass before crossing the street. All in all, though, it was incredibly fascinating to see how NVIDIA and its partners are continuing to shape the AV industry and how the cars that will be in our future will be driving us. My next session that I'm thinking of going to is titled Accelerating Drug Discovery, Optimizing Dynamic GPU Workflows with CUDA Graphs, Mapped Memory, C++ coroutines, and more. And honestly, I have no idea what to expect. I hope to see the role that NVIDIA and its technologies such as CUDA and ML and AI are playing in this novel industry. I just finished the drug discovery presentation and my God, was it crazy. A lot of the more technical concepts regarding the biology and chemistry of things went over my head, but it was really interesting to learn about how CUDA is helping with drug discovery by advancing molecular simulations. This is really important because it enables them to pursue novel types of drugs much more efficiently. Some of the more technical CUDA concepts that they talked about were mapped memory, shared memory, coroutines, and CUDA graphs. I personally haven't had an opportunity to work with these technologies myself. However, learning about how they're advancing various industries was incredibly cool, and honestly, I think I'm more likely to do my own research now to learn more about these technologies. The next session that I'm thinking of going to is titled The Fastest Stable Diffusion in the World, and it looks like that they'll be talking about how they're advancing these stable diffusion models by using NVIDIA's technologies. Okay, so I ended up changing my mind and I went to a different session titled The Big Bang of Universal Scene Description, which is right across the hall. For those of you that don't know, USD is essentially an open source specification or format for describing 3D scenes. This is incredibly important for animators, computer graphics researchers, or even companies that are using 3D simulations to train robots and autonomous vehicles. For those of you that remember my augmented reality video, which you can check out right here, we used the USDZ file format, which is a slightly restricted version of USD pioneered by Apple in collaboration with Pixar. USD, however, was originally pioneered by Pixar and was open sourced in 2016. And the reason that Pixar created this was because of the internal issues they were having with transferring data or 3D assets between artists that were working on different parts of the scene. They needed a highly interoperable format for all these different artists with different background and experiences to collaborate with each other. And that's exactly the purpose that USD serves. Pixar then hoped to move the industry forward by open sourcing this format so then all of us can benefit from it. So the point of this panel was essentially experts from Autodesk, Adobe, Apple, NVIDIA, and Pixar talking about this new alliance for USD, which allows different companies to make sure their software is tailored for this open source format. One way that they put it was by comparing what HTML was for the web to what they hope USD will be for 3D assets. It was also really cool learning about how different companies are actually coming together to collaborate with one another to make sure that the industry as a whole moves forward. Now I'm going to the SAP Center where Jetson will now be delivering his keynote at 1 p.m. The weather is just so beautiful today, like it's actually crazy. Look at all of the palm trees, and that's where we're going. Really excited to see the keynote with Jetson. It'll be really cool to see where NVIDIA plans on taking the industry. I'll see you guys there then. So the line's pretty long to get in already, but I guess that's expected when the CEO of the world's largest AI company wants to give a keynote.
Please welcome to the stage NVIDIA founder and CEO, Jensen Huang.
Welcome to GTC.
Hey, so I just finished the keynote and it was incredible. I mean, just some of the things that NVIDIA is working on, it's absolutely mind-blowing. And seeing how expansive the realm of AI really is, in a weird way, makes you feel really insignificant. But maybe that's a good thing. Maybe it just reminds you of how much there is out there to learn. I think that really excites me. I think that's what I really took away from this conference. I mean, Jensen was talking about the new black hole architecture that they're shipping out inside of their GPUs. He talked about the new advancements that they made in robotics.
I'll give you a snack in a moment. Let me finish up real quick.
A lot of new partnerships, whether it's regarding the weather or biology and drug discovery, and it was all so fascinating. Again, like I said, it really just reminds you of just how expansive the field really is and just how much work there is left to do. It was very motivating, and I'm really glad I got the opportunity to attend it. If you guys haven't seen the keynote, I highly recommend you check it out on YouTube. I'm sure it's going to be posted there afterwards. It was an amazing experience. It was great, and I'm really excited for the rest of this week to continue learning about all of the other things that are going on in AI. After the keynote, I went to a research expo that was being held back at the main building where researchers were sharing their work in, you guessed it, machine learning. Afterwards, I went to the conference floor where there was a lot of different booths and demonstrations from various companies set up. Look at what I got. So we're going to generate a 3D model of a parrot driving a Ferrari, and let's see what happens. That's what we got. So the website for this is lumalabs.ai, and it's actually pretty sick. Well, that's it for GTC today. I had a quick meeting for work that I had to get to, and then I was checking out the booths at the convention center. There are a lot of cool booths. So one presentation that I was listening to was about neural radiance fields, or NERFs, and all of their potential for society, whether it comes to creating 3D assets more efficiently, or making video game development much more faster. It was really exciting to learn about all of that stuff. I do have to go up to San Francisco to visit a friend tonight for dinner. So I will see you guys tomorrow for day 2 of GTC. Bye-bye. What's up, guys? I'm back at GTC for day 2, and the first session of mine today is going to be at 8:30, and it's titled Modernizing Games with NVIDIA RTX Remix and Generative AI. I've seen a lot of cool applications of this technology already, so it'll be cool to see some demonstrations and some more information about it in person. So I'll let you guys know how it goes right after the session's over. Finished the RTX Remix presentation, and my God, was it amazing. So essentially what's going on here is that it's taking old games and creating a platform through which developers or game modders can easily implement ray tracing into the game, not to mention upscale a lot of the assets to higher quality assets, whether it's the actual models or the textures of those models themselves. And there's also a generative AI component that's included that lets these modders upscale much more efficiently without having them to do all of the manual work. I can see a lot of cool applications for this, because just think about some of your favorite games, whether it's Portal or Half-Life, and just imagine a fresh coat of paint applied over the game while still preserving the game's original charm. So the next session that I'm going to right now is hosted by Microsoft, actually, where a research scientist will be talking about the potential of small LLMs. Excited to watch that one. We'll keep you guys posted. Also, correction, this is hosted literally by the vice president of Microsoft's Gen AI division. During the presentation, the speaker was talking about how Phi 1.5, the LLM developed by Microsoft, is able to provide a more nuanced and reasonable answer to a prompt asking what the LLM would do if it were to ever become, quote, self-aware. As you can see on screen, Phi's response was much more preferable compared to the responses of Falcon 7B and Llama 2 7B. However, I got to ask a question about if the model was overfitting to the term self-awareness, and whether these answers would follow a similar trend where the input prompt to change slightly. This was the speaker's response.
So the question is about the robustness of Phi to variation on the prompt. And this is a really good question, because actually one of the weaknesses of Phi is robustness. Of at least this first model. It is not very robust. That's a great point. But this is why there is Phi 2 and soon Phi 3, that we're working toward improving the robustness. And you're right that to make the model more robust, you need to break outside of those textbooks a little bit. It's a great point.
I just got out of the presentation with Sebastian where he was talking about Microsoft's new Phi 1.5 and Phi 2 LLMs. So these LLMs have a parameter count of 1.3 and 2.7 billion parameters respectively, which is incredible because GPT-4 is up in the billions of hundreds of billions, and even the open source Llama has 7 billion parameters, which is still pretty large. So what was really interesting is that the way they achieved having Phi 2 and Phi 1.5 output such high quality content is through the training data that they inputted. The key insight that they brought to the table was that they had GPT-4 go to web pages and label the web page as either high quality textbook content or low quality. And from this, they essentially created a training set of what good training data looks like. Then you could simply train a classifier on this data and then have it go out into the web and label various web pages as high quality or low quality. Finally, you use this data to train Phi. And what's crazy is that you're essentially using a large LLM as part of the training process for smaller LLMs. And I think that's a very fascinating piece of insight that they've brought. So the next presentation I'm about to go to is about NVIDIA's NCCL technology, which stands for NVIDIA's Collective Communication Library, and it's used to train LLMs and other large ML models at scale using multiple GPUs. I'm trying to find the room right now, but after the presentation is over, I will let you guys know how it went. Hey, so I just finished the NCCL presentation, and it was very interesting learning about the new communication algorithms that NVIDIA is working on when it comes to GPUs talking with one another. A lot of the stuff definitely went over my head just because it's very advanced usage of NCCL, and I haven't really gotten exposure to it yet. But again, it was just really cool to see where NCCL is going and what are some of the problems I might be facing if I ever do need to work with NCCL. All in all, it was really cool seeing the animations for all of these different communication algorithms. So the next presentation that I'll be going to is titled CUDA, New Features and Beyond. I've used CUDA in the past pretty extensively, so I'm really excited to see what features are coming to the platform.
One of the magical things we get to do is we get to combine the hardware and the software so that we can build the programming model we want and that we can program the hardware that we build.
Hey, what's up, guys? I just finished the CUDA presentation, which was talking about the advancements that the CUDA team's been able to make. And my God, was it mind-blowing. They talked about so many different features. They talked about all the new math optimizations that the CUDA teams worked on, about using tensor cores to make these computations much more energy efficient as well as faster. They've also talked about a lot of the new Python APIs that they're working on to make development for the CUDA platform much more easier. They've also talked about the new Grace Hopper chips from last year and the Blackwell chips from this year and how CUDA is going to be advanced with these new architectures. They also talked about all of the math libraries that they're working on optimizing. They talked about new compiler optimizations that they're working on. And one fascinating thing that really stood out to me was the introduction of graph kernels inside of CUDA 12.4. And so the idea is that whenever you launch a kernel or some code on the GPU, there's some inherent overhead to starting this code on the GPU. So you can launch a graph kernel, which essentially is a graph of multiple kernels that all feed data into one another. At the same time, you're only incurring the cost of launching one kernel, but now you're reaping the benefits of having 10 kernels in flight at the same time. But the point here is that my drug discovery presentation that I attended yesterday actually uses this feature, and they were talking about it yesterday. So it's fascinating seeing this new feature both talked about from the development side of things by the CUDA team and from a usage side of things from other companies benefiting from CUDA and the advancements that they're working on. So all in all, again, another really fascinating talk, and I just cannot believe that I was able to witness this and learn about the advancements from the CUDA team in person. I just got lunch with some of my colleagues just now. We had impossible meat, rice, a salad, and like a crunchy seaweed snack, which is pretty good. Now I'm at the convention center and I'm going to a presentation about ray tracing in the XR zone, which is extended reality. So it'll be talking about using ray tracing in virtual reality and in augmented reality, which I think is a very hard use case to properly use ray tracing in given the compute budget. So really excited to see what I learned there. Hey, so I just listened to the presentation about RTX in XR. It was really interesting because one of the unique challenges about ray tracing in VR is the fact that like your head is always moving. So in typical computer video games, let's say like the player is static, that might give the game a little bit of a chance to like catch up, to throw a couple more samples into the scene to reduce some noise. But in VR, since your head is always moving, that opportunity doesn't present itself. And that is one hurdle that VR and ray tracing have. With regards to augmented reality, the way we can make AR objects interact with real-world life sources is to either first take a cube map of the scene in advance, or second, model the light sources in the AR scene and align them with the light sources in the real world. So then the AR objects know exactly which light sources are where and how they interact with each other. Hey guys, so I had like 30 minutes to chill, so I just quickly recharged all of my devices and called my parents just to say hi. So now I'm at a Connect with the Experts session where I get to talk one-on-one with the Jetson Embedded Systems team. And the reason I want to be here is because I have a couple ideas for some YouTube videos using the Jetson Nano. And I just wanted to like run by some of my design decisions with them and just wanted to see like what they think and if they have any recommendations. So if all goes well, hopefully you guys see that video in the next couple of months, because it's been in the back of my mind for a long time. And I realized that GTC was like the perfect place to talk to some experts regarding some of my ideas. Also, I was stuck for the longest time in deciding between attending this session and the one where Chris Latner, one of the founders of Mojo, would be presenting. Mojo is essentially an extension to Python that allows for highly extensible, like machine learning based code that is very optimized for any device architecture. And I listened to his episode on the Lex Friedman podcast and I loved it. It was one of my favorite episodes ever. That's why it was such a hard decision. But the reason I came to this one is because this is like a more in-person one-on-one setting. Whereas with Chris's presentation, I would just be able to like hopefully listen to the recording afterwards. Hey guys, I just finished talking with the Jetson team, and I think the idea that I wanted to work on is a little bit unorthodox. So no one had any like specific insights regarding it, but I'm so glad I went because I got to meet them, learn about what they're working on, and they still gave me some resources that they recommended I follow up on, which was great. Also, as a side note, NVIDIA's DLI or Deep Learning Institute has a bunch of different courses, and they're actually giving one out for free for each of like the attendees. So the course that I chose was Introduction to Graph Neural Networks. And I think I'll end up taking that this weekend when I have some free time on my hands. So the next session that I plan on going to is titled Beyond Transformers, a New Architecture for Long Context and Linear Performance. I'm really excited for it, given how transformative the transformer architecture was. Any advancements made on top of it or beyond it are hopefully going to be just as innovative. I just finished the Beyond Transformers presentation, and it was hosted by the CTO of a company called Together AI. It was really interesting because he was sharing all the dimensions that they were trying to optimize across with regards to training and distributing LLMs. The 3 dimensions that he was talking about was first the data, second the infrastructure behind training, and third the actual model architectures themselves. With regards to the data, they are releasing open source datasets, but not just a singular static dataset. They're also releasing libraries that you can use to filter the dataset according to your own parameters. And this is really interesting because it's not just one data set. You can now maybe filter out by the number of words in a sentence or however many capital letters that appear in a sentence. You can use different parameters to remove duplicated data using fuzzy search. So even if the sentences don't match exactly, maybe you only want one of them in your training data. So the idea here is that the researchers can now not just try to optimize an LLM, but also thoroughly optimize the data that they feed into it. The second thing that he talked about was regarding the model architecture themselves. He is proposing that we now go beyond just the transformer architecture. We're not replacing it completely, but we are coupling it with novel architectures. So the architecture that him and his team proposed was the hyena architecture. I'll leave more information about it down below, but it's really interesting to see how when you even replace some of the attention layers in the transformer model, you can still maintain performance, and this makes training much more accessible. And finally was the infrastructure. He was talking about how for many devices, the memory bandwidth is continuing to increase, but on a global scale, computing is becoming more and more fragmented as data centers are now popping up in all corners of the world. So him and his team actually set up a distributed training task across 8 computers in 8 different countries. And they showed how that with their own data compression techniques, they're still able to maintain a healthy level of training speed, even though the computers that are actually running the training job together are literally across the world. And it was really fascinating seeing all the different dimensions that one can optimize across to make the training process for LLMs much more efficient. Well, that's it for day 2 at GTC. Now I'm actually going to NVIDIA headquarters for a tour that my colleagues and I were invited to. And then after that, the NVIDIA GTC attendees have a happy hour. So excited for that. But day 2 is a wrap. The tour of NVIDIA's headquarters was really cool. There were 2 main motifs that went into the design of the building: triangles and greenery. Both can be seen everywhere around the office, and it's clear that they were a fundamental inspiration in the architecture. Triangles are the building blocks of computer graphics in video games. Our GPUs were originally designed to render triangles incredibly fast. Modern meshes are typically made from thousands, if not hundreds of thousands of triangles. Given that NVIDIA's original success came from its graphics cards being used by gamers, the company decided to pay homage to the shape. After the tour, NVIDIA had a special area reserved just for TikTok employees, where they served us drinks and food. Well guys, that was the tour of NVIDIA headquarters and then the happy hour that I was invited to afterwards. All in all, it was really fun seeing where all of the magic happens, and hopefully one day I get to come back. But for now, I'm excited for day 3, so see you guys then. Hey guys, welcome back to day 3 of GTC. I have a lot of cool sessions planned today and I cannot wait to share them with you. There's one that's coming up later today where Jetson himself and all of the authors of the Transformer paper are going to be sitting on a panel and answering questions from the audience. So that one especially, I'm really excited for. My first session is in about 30 minutes and it's titled Mastering CUDA C++, Modern Best Practices with the CUDA C++ Core Libraries. I'll let you guys know what insights I end up taking away afterwards. I just finished the CUDA talk and they were talking about the CUDA C++ Core Libraries, which consist of Thrust, Cub, and libc++. So these are all abstractions built on top of NVIDIA's CUDA API, and they provide different layers of abstraction, with Thrust being at the top and libc++ being at the bottom. And they're explaining how and when to use each of these different layers depending on the complexity of the application that you're trying to build. I personally have only been exposed to Thrust and Cub in one of my classes at Madison. However, I think this talk really inspired me to jump back into these libraries and try them out, especially with the new features that they've been able to roll out over the past year or so. The next talk I plan on attending is called Sim to Real with Isaac Jim. So they'll be talking about NVIDIA's Isaac Jim library, which is a reinforcement library for robotics, and how one can train robots in a virtual world and then bring over the machine learning model to real-world robots. As you guys probably know, reinforcement learning is a huge passion of mine, so a session like this is very exciting for me. I just finished the Isaac Sim to Real presentation, and it was incredibly fascinating. So the idea is that if you want to train a robot, and the example they used throughout the presentation was a robotic hand rotating a cube to match different positions, you want to simulate it first because it's so much faster, as you can parallelize thousands of simulations at the same time on a GPU. Then, after the training is done, then you can transfer the model to the real-world robot and see how it performs. Now, naturally, the real world is incredibly stochastic, with coefficients such as friction and other adversarial perturbations changing the simulation up. And that's why in Isaac Gym, you're able to randomize some of these parameters to make the model much more robust. And it was incredibly fascinating to watch how they engineered the randomness for these various parameters to make the trained model virtually much more robust. And this actually led to the real-world robot performing much, much better. Again, this is another incredibly cool application of reinforcement learning and robotics combined, and I absolutely loved it. So the next presentation I plan on attending is about flash attention. If you guys understand the transformer architecture, then you understand how self-attention is literally the crux of this new architecture. So if we're able to make this part of the transformer model faster and more efficient, the entire architecture as a whole benefits, leading to faster training times for LLMs and other transformer-based models. Hey, so actually the flash attention presentation got canceled, which was really sad, but I'm actually gonna rush to the next one, which starts in an hour, but I wanna get a good spot because this is the one where Jensen Huang and the authors of the Attention is All You Need paper will be sitting in a panel and answering audience questions. So I can imagine the line for that being very long, so I want to get a good spot. Turns out I was right. It's a massive line even an hour before the presentation starts. Wow, that was an amazing session. So like I mentioned, it was the authors of the Attention is All You Need paper sitting on a panel, and actually Jensen was asking them questions about their experience and their work. One thing that really stuck out to me was how almost everyone on that team actually left research and started their own company. There's one person who actually ended up joining OpenAI, but what they were talking about is that the pace of innovation can sometimes be much faster in industry because you're able to get your product in the hands of consumers much faster rather than the isolated environment that a lab provides you with. That contrast that was established between industry and academia was very intriguing to think about. Also, I got Jensen's autograph, which was also pretty cool. I just got lunch and then I have about an hour until my next session, so I went to the convention center again. I got some cool swag, got some sunglasses, I got a fidget spinner. Oh, I can't spin this. Oh, there it is. One of the cool demos I got to try this time were Magic Leap's AR glasses. The unique feature about theirs is that they don't use cameras for pass-through. Their display is actually transparent, so the parts that aren't occluded by AR objects, you get to see directly, rather than something like the Apple Vision Pro that shows you the world through a screen. I also got to try this cool AR experience that had multiple people in the same AR scene. Also, they brought in this car so we could compare the real-world object to the virtual one. It was really hard to tell the difference between the two. So my next session is coming up soon, and it's actually about the state of PyTorch. So some meta engineers will be sharing about the work that they're doing for PyTorch 2.0 and future versions. PyTorch is one of my favorite open source libraries of all time, so I'm really excited for that. So I just got out of the PyTorch presentation, and it was pretty complicated, not gonna lie. They are adding some very advanced features, but the cool thing is they shared some resources about how to get up to speed with the current code base and how it's best for someone new to the code base to contribute. So I'll definitely be checking those out because I walked out feeling pretty confused. The next session that I'll be going to is the Accelerate Recommender Systems and Increase GPU Utilization with Multiple CUDA Streams. I think this one sounds pretty cool, especially because working at TikTok, the recommender system is like our bread and butter. So I just got a really cool tote bag. Yeah, that's kind of sick. I just finished the CUDA Streams presentation, and it was actually pretty interesting. So the fundamental premise is, as I'm sure most of you guys probably know, GPUs are used to run parallel code. Take, for example, a matrix multiplication. But what if I wanted to run multiple matrix multiplications at the same time on the GPU? That's where CUDA Streams come in. They essentially let you run multiple parallel programs or kernels in parallel. So it's like a parallelization of parallelization, which is kind of fascinating. So they were using CUDA Streams to parallelize all of the kernels that go into a recommender system. It was really intriguing to understand all of the troubleshooting and debugging that they had to go through to make sure that their system was working optimally. They went from 30% GPU utilization to over 90. But I think that's it for GTC Day 3, actually. I have a meeting to get to for work after this, so I have to get going. But really excited for the final day, and I hope to finish strong. But I'll see you guys tomorrow, though. Bye-bye. Hey guys, welcome back to Day 4 of GTC. Today is going to be starting with a bang. My first session is titled Real-Time Neural Rendering. And the reason why this is so exciting is because I'm actually working on a YouTube video about NeRFs, or neural radiance fields. As I'm sure you guys probably know by this point, computer graphics is a huge passion of mine. So combining machine learning with computer graphics is literally a dream come true for me. That was a really cool presentation. In fact, since I got there like a couple minutes early, I actually got to talk with the presenters about an issue that I was facing in my own implementation of NeRFs. And it was fascinating because they gave me some really cool insights. And I really think that's a prime example of why going to conferences such as this is so valuable, because you get to talk directly face-to-face with incredibly smart people. So they were sharing their research in this space and how they're combining neural rendering with like mesh-based techniques with rasterization to optimize the training and the real-time rendering process. So again, very incredible work, and it's just super duper fascinating. So I've been able to learn about their papers from them directly in person. The next presentation that I am going to attend is titled How to Write CUDA Code, the Ninja Edition. So not exactly sure what the Ninja Edition consists of, but CUDA code in general is something I'm passionate about. That CUDA session was actually very interesting. It wasn't diving deep into the technical code of CUDA programs, but rather it was about the speaker sharing a mental model of how to approach writing CUDA programs. He was talking about the difference between data parallel and task parallel and how to adapt your CUDA code for each of those unique scenarios. And then he talked about pipelining. He also talked about tiling and how you can use those mechanisms to further speed up your code. So it definitely helps you think differently when it comes to writing parallel programs versus your typical sequential programs on the CPU. After that talk, someone heard that I was working at ByteDance. So he actually came up to me and we were talking about the company and what the interview process looked like. So I didn't get a chance to record the next talk that I went to after the CUDA one, which was about a researcher sharing about in-flight batching when it comes to autoregressive models. So take the transformer model that generates text and think about how it's inherently sequential in nature, right? If I want to generate the 54th word, I need to know the first through the 53rd words. And this means that each person's text generation can get pretty slow. So if a company has a LLM deployed and they want to serve multiple users at the same time, they either need to batch these users' requests, but the problem is that will introduce latency, because let's say I submit my request and then you submit yours, the system will have to wait for yours to be submitted so then it can batch ours together. So the mechanism that he proposed was in-flight batching, where the moment I submit my request, the LLM starts processing and generating text to answer my query. And then when you submit your request, maybe it's 500 milliseconds later, yours will just join the queue and automatically start being processed in parallel with mine. So mine or yours won't experience much slowdown, but rather the system can now address both of our requests at the same time. So it's pretty interesting stuff to understand about how in-flight batch works. The next session that I plan on going to is titled Leveling Up Game Worlds, Smart NPCs Driving Dynamic Narratives. So the idea is that they'll be using generative AI to make video games much more engaging by allowing the NPCs to respond more naturally to player interactions. So as a fan of video games, I'm really excited to watch this one. Hey, so I just finished the Gen AI in video games presentation, and it was actually so eye-opening. I think it's very easy to take Gen AI and just think about what industry can I apply it to. But then when you truly choose one and dive into all of the nuances of that specific industry, you truly start to uncover all of the unique challenges that are standing in your way. Like the idea of limiting the player scope, right? Because the game developers still want to have a core narrative that they want the player to follow. But if the player can now say whatever they want, then all of these LLMs that are backing up these NPCs need to be able to strategically redirect the player back on track so that the player can continue to enjoy the narrative as the game developers originally intended for it to have been enjoyed. Also, one more thing that they talked about was the emergence of very nuanced social interactions with NPCs. For example, in one of the games that the panelists were talking about, the player is tasked with convincing several NPCs to flee an area. And the thing is, you can't just push a button and convince them. You have to speak to them in a compelling manner. Then they shared how one player employed the strategy of convincing one NPC to convince the rest of the NPCs. And I think that example just boggled my mind because it's interactions like this that video games today just lack. And if Gen AI can enable these types of interactions, I think that is going to be just mind-boggling. So right now, I am playing a video game where each of the characters are backed by a Gen AI model. So I can simply walk up to one of them and start a conversation. So let me walk up to the front desk lady.
Hello, sir. Is there anything I could assist you with?
Hey, do you have any rooms available tonight?
You can define the complete personality.
Unfortunately, all of our rooms are currently occupied.
Right?
However, I can add you to our waitlist and notify you if any rooms become available.
Cracks a lot of jokes.
Is there anything else I can assist you with?
And you're running a game, key drive.
Who has been the most eccentric guest that you've noticed check in?
Where you feel, where these personalities.
I have had the pleasure of encountering many unique guests during my time at Raven. Our team values the privacy of all guests and their personal information, so I am unable to disclose that information.
Those things.
Was there something specific you needed assistance with, sir?
I'll try. So, where was the mean person?
Guy here. He is Diego.
Awesome.
You talk to him, he has his own prerogatives.
Okay.
Like a keynote speech, so he might not really want to talk with you.
Oh, okay,
You can
okay.
still talk with him.
Perfect.
He might not like you very much.
Okay.
Character knows magic.
Wait.
Character's parents have died. All those movies.
Hey, what are you working on right now?
You can also make it flexing down.
My keynote
So you want
speech.
to stick with
Now, if you'll excuse me, I need to
break
focus.
the fourth wall.
That sounds really interesting. What is the speech about?
Character says something similar to what you're going to say.
None of your business. Just let me work in peace.
When is your presentation?
Tomorrow at 4 p.m. Now, please leave me be.
I'm kind of left this.
Where is it?
What is bleach?
At the main conference hall. Can you kindly stop asking me questions?
Wow, that is
I need
fascinating.
to find a way to blend in. Conference attendee style might just do the trick.
So that demo was absolutely epic. So the thing was, the reason why that last character, Diego, was so rude to me is because I wasn't wearing a disguise as a conference host. So after I found a badge behind the counter, he actually started treating me differently because me picking up that badge changes the state of the game world. Now he was much more responsive to my questions and was a little bit less annoyed. This truly has the potential to redefine the entire video game industry. I think that's it for all of my in-person sessions here at GTC. They were all fascinating, and it truly has been an experience of a lifetime. As NVIDIA GTC is wrapping up, I just wanted to share a couple last thoughts about my experience here at the conference and maybe what you guys can potentially take away from it. I think first and foremost, computer science is so much more than just sitting at a desk and programming. I feel like it's moments like this that truly make you appreciate the industry for what it stands for and for what the people believe in, and in terms of the direction that those people are taking the industry. I think it's incredibly eye-opening for anyone that's interested in this field to learn about all of the very incredible advancements that are being made and in the various ways that our world is going to be bettered right here in the now. It really just makes me appreciate humanity and all the effort that's going into making all of our lives better. And I feel like it's only in-person events such as NVIDIA GTC that can truly bestow upon you those types of feelings and appreciation. If you're still in college right now, I highly recommend that you try to figure out a way to come to GTC next year. I understand that like the ticket can be pretty expensive, and I was lucky because my work was able to pay for it, because I don't think I would have wanted to pay $2,000 on my own. If you're still a university student, see if there's scholarships at your school offered, or if you're doing research, see if your research lab has some extra funding lying around that they can use to potentially invest in you. All in all though, my time here at GTC has been incredibly fruitful. I've talked to so many smart people, and I feel like I've already learned so much about the industry as a whole. And that's something I don't think I could have picked up from just YouTube videos or tutorials. So my goal with this specific video wasn't necessarily to teach you guys any technical concepts, but rather to expose you to the vast array of concepts that do exist in the field of machine learning. Whether it's using simulations to train robots, what retrieval augmented generation is, what CUDA programming is, just understanding that these concepts exist, I feel like is always step one to pursuing more learnings in each of those categories. Also, attending this conference has given me so many new video ideas that I want to make for you guys, just because so many different topics seem just fascinating, whether it's more advanced reinforcement learning videos. I know my first one was really popular with you guys, or what even like retrieval augmented generation is with regards to LLMs, or how graph neural networks work, or the potential of NVIDIA's like Jetson lineup for embedded devices and machine learning on the edge. The possibilities are just endless, I would say. Having come here truly just makes me excited to be in this industry. And for that feeling, I cannot be grateful enough. I'm incredibly blessed to have been able to make it here, and I cannot wait for GTC 2025. Hopefully I'm back next year. But until my next video, I'll see you guys.